Group will be reviewing and presenting the article titled Warming and Earlier Spring Increase Western U.S. Forest Wildfire Activity. Our group members are Ryan Finlayson, Jonathan Hale, Andrew Herrera, Shay Nolan, Lily Paul, and Riley Wright. To introduce the article, we will be discussing what the most recent wildfire trends have been and what's causing them. Since the 1970s, western regions of the U.S. has experienced high volumes of wildfires, leading to extensive damage. The article states that federal land management agencies spend over $1 billion each year on firefighting expenditures. Just last year in 2020, California tripled the amount of wildfire spending in 2005, reaching over $3 billion. This high frequency of wildfires and the expensive destruction that they cause has drawn the attention of legislative and administrative action. Scientists have proposed that land use and climate change may play major roles in causing these wildfire phenomena. The article discusses potential solutions like fuel management and ecological restoration. However, if climate change is not the primary cause, these solutions would be relatively ineffective and insufficient. To test the two causes, the authors studied 34 years of wildfire history in western United States regions. They also used hydroclimatic data, which combines the study of hydrology and climate on Earth to determine the causes of the fires. They also evaluated climatic trends over the past few decades. One climatic trend they studied is the earlier emergence of spring weather throughout the years, which will also be discussed in the report.
Hello, my name is Ryan Finlayson, and I'm going to be talking about climate versus management. So when it comes to wildfires, there are two main competing explanations for the current trend of wildfire activity. These two competing ideas are land use theory and climate theory. So in summation, land use explanation relies on historical significance of the land, and this can be in terms of livestock, grazing, logging, deforestation, and other things. So this basically means just whatever the land had been used for previously could serve as some indicators as to whether or not the land is more apt to catch on fire. Things like livestock and grazing would hurt damage the soil from having constant pressure being applied by the livestock and taking up things from the roots and making just a more dry and arid environment. And logging and deforestation kind of follows in the same path, in which it would make it more apt to catch on fire because it would mess with the way that the biomass is distributed in that specific area. And then the climate theory relies on changing climatic variables like moisture, temperature, presence, and biomass, etc. So this means that the amount of wildfires is kind of indicated by maybe average temperatures, the amount of moisture in the soil, presence of biomass, is there a lot of trees or there are a lot of vegetation present, and those would serve as main indicators as to the amount of wildfire. Here I've placed a graph from our reading which shows the wildfire frequency compared to that of temperature, spring snow melt, and fire season length. So if we look at that top one, this kind of ties into the climate theory or the climate explanation, in which the amount of frequency kind of has a correlation to the average temperature at that time. There you go. And then some similarities and differences between the two theories. For similarities, it can be argued that there is a positive correlation between the two theories. For example, land use can increase the sensitivity of a forest to change in terms of climate, hence more fires. So the way that the land has been used in the past historically could alter the way that that area responds to certain climatic variables. Maybe it helps it increase the temperature or redistributes the amount of biomass in certain areas, and that would lead to an influx of wildfires at that particular time. Differences, it could be argued once again that there is no correlation, and this can be seen in the southwest of the United States, in which that area is really determined, the climate of that area is really determined by the way that the ocean is and the sea temperature and pressure and moisture in the air, and those areas are more apt to catch on fire and have wildfires, even though the historical land use of that area is negligible in terms of examining how wildfires, like how prominent they are in that area.
The topic of our article is global warming and links to forest fires in the Western United States. Our first topic in the article is increased forest fire activity. This is demonstrated through figures 1A, B, and C. In figure 1A, it's comparing the annual frequency of large western U.S. forest fires with the bars and the mean temperature from March through August for western U.S. with the lines. As you can see, the lines usually directly correspond with the wildfire rates. In 1B, it's talking about the first principal component of center timing, stream flow, and snowmelt dominated streams. Tensile values indicate the time of snowmelt. So with the earlier snowmelt, the dots would be in the lower part represented by a pink highlight. If it had a later snowmelt, it would be in the parts with the blue highlight. If it had an earlier snowmelt, then it usually corresponds with a large amount of forest fires during that time, as increased temperatures due to global warming. Figure 1C, it compares the annual time between the first and last forest fire ignition and the last fire control. This shows how big this can show how big the forest fires were and how they were not easily controlled and how often they were due to global warming and the increase of temperatures. The next topic covered in the article was fire activity and the timing of the spring snowmelt. This is shown through figures 2 and 3. In figures 2A and B, first, we will talk about those. In figures 2A, it's talking about the correlation between annual western U.S. large forest fire frequency and stream flow center timing. This shows that with the earlier time that spring snowmelt happened, there was a larger amount of forest fires, as shown through the dots on the screen. The bigger the dots and how close they were together shows how often there was a forest wildfire, and due to the global warming and how fast the snow was melting. And 2B, it's talking about it's comparing the average frequency of western U.S. forest fire by elevation and early midnight snowmelt from years 1970 to 2002. Whenever there was an earlier spring snowmelt, it had a higher average wildfire frequency. This is due to global warming, as whenever the world would heat up more and the snow would melt faster, it also would cause many crops to dry out faster, and just the rise in temperature caused for dry vegetation in general, which makes it a lot easier to catch on fire compared to normal vegetation. And figures 3A and B is talking about the average difference between early and late snowmelt years and average precipitation from October and May. And then in B, it's talking about the average temp between March and August. As you can see, very obviously, the western U.S. has higher temperatures, but also very much lower amounts of precipitation, which makes them very prone to wildfires, as dry vegetation catches on fire very easily. For figures 4, it's talking about the index of forest vulnerability to changes in the timing of spring. The percentage difference in the cumulative moisture deficit from October and August at each grid point in early versus low snowmelt year. It's basically comparing the forest area, like how vulnerable they are compared by it's comparing how vulnerable they are compared to how dry they are due to early snowmelt as well. As you can see, the areas that were covered in figure 3, those areas in there that had the lower amount of precipitation and the higher amount of degrees also are very vulnerable to forest fires, which is very dangerous for the environment.
All right, so for the first part of the results, this is going over the increase of the forest wildfires. So there was an increase in these forest wildfires, and it was about 4 times the normal average. in these forested areas. The surface area, or the area being burned, also increased, and that increased by about 6.5 times what the previous level was. And down here, figure A is a graph showing the comparison of the wildfire frequency and the temperatures of the year. And you can see it starts off in the 1970s, it goes up to the 2000s. You can see as how the temperature is increasing as time goes on, and so is wildfire frequency. And you can also notice how they correlate, because when the temperature dips, so does the wildfires. There's a lesser amount. The length of the wildfire season also increased by about 64%, which is also 78 days. And figure C over here, you can tell how it's starting off lower. You see day of the year, it's starting off way lower and lasting a lot longer than in the 1970s. And it's just slowly increasing. The average time of discovery and control of these wildfires also increased from 7.5 days to 37.1 days. The largest increase in these fires was in the Northern Rockies, and that actually makes up 60% of all these wildfires, 60% of the increase. And the Southwest also increased. It's just not as noticeable compared to Northern Rockies because of how little makeup or how little the area is. But they both did show equal trends, just one being more significant than the other. The Southwest having a smaller contribution to the total, but the wildfire frequency did concentrate in the elevations of around 1,680 meters and 2,590 meters, the greatest increase being about 2,130 meters. And around these elevations, wildfire activity has been, it has come in waves or pulses, with being a lot more frequent in the warmer years and slowing down in the cooler years, which is also associated with changes in spring and snowmelt timing, which is sensitive to the changes in temperature.
Well, my name is Jonathan Hill, and I'll be talking about the fire activity and timing of spring snowmelt of the results. Through the results, it was shown to have a correlation through early snowmelt and the number of wildfires. This is a negative, outlook, but it had a positive correlation with it. It also showed that the late snowmelt resulted in the least number of wildfires. Another observation was the temperatures also increased with the earlier snowmelts rather than the late snowmelt. So we can assume that earlier snowmelts meant a drier and hotter summer, while the late one, you'd have a little bit more moisture and it'd cut down some of the wildfires. The graphs, you can see the first graph, you can see that the early snowmelt had a significantly higher wildfire frequency. In contrast, the late snowmelt had the lowest out of all of them. And the second two of the figures, figure A is the early snowmelt and its temperatures. And you can see it's a huge difference compared to the late snowmelt's temperatures.
Analysis section, we can associate the shift from shorter and periodic wildfires to frequently long wildfires with global warming and climate change, specifically warmer springs and longer dry seasons in the summer, which can result in drier vegetation, which is essentially kindling. We can also connect this with reduced snowfall and early snowmelts, considering early snowmelts often lead to earlier springs, which leads to an increased moisture deficit by midsummer. We can also connect historical use of land to the risk of wildfires, including deforestation and mining, considering that it can result in smaller larger densities in the forest, whereas you have a large range with land alterations, you have smaller pockets of forest that can easily catch on fire. However, the reasons for wildfire prevalence can vary based off region. For example, the Northern Rockies has the greatest absolute increase in wildfires, but this is due to climate change. So it has early springs and increased moisture deficits by midsummer. In contrast, you have Northern California, which has effects that are caused by climate and land use deficits. So the land use deficits enhances the effect of climate change, such as timber harvesting and mining activities. And while historical use of land is important to consider, the overall cause for most wildfires is global warming and climate change. So why is this important? Well, it urges us to push for ecological restoration and reducing wildfire risks in communities that are susceptible and sensible to destruction from wildfires. With forests that have undergone land alterations, we can focus on ecological restoration due to increased forest density. However, in regions where land alteration has had little impact, we will require a greater effort than ecological restoration to reverse the current rate of wildfires. So what is the regional and global impact of this? Well, regionally, there is local destruction of homes and buildings and the local ecology. Globally, the United States can emit a larger carbon footprint than what it had before, whereas these trees were decreasing carbon emissions. Now they will be increasing them with these wildfires. So globally, our carbon footprint will be much larger, which can increase the global impact of global